Before we proceed with our experiment, let's take a little bit of time to recap on our knowledge on pumps. In general, there are two ways of connecting two pumps. It's either in series or parallel. Starting with pumps in series. Looking at the schematic over here, you can clearly see that there is only one inlet involved. What does that mean? It means that Q total is simply Q1 equals to Q2. But when it comes to H values, going through two pumps, there will be two regions where you have an increase in pressure. So to better understand this, I'm going to draw an arrow indicating the rise in pressure across pump 1 and also a rise in pressure across pump 2. And that means that the H total for the pumps in series is the combination of the rise in pressure of the first pump, also the rise in pressure in the second pump. So it's H1 plus H2. To better understand this phenomena, let's plot the H and Q on a pump performance curve. Looking at the graph over here, at a specific Q value, which I'm going to name Q0, we're going to have a different H values over here, simply because of those two particular pressure increase that I mentioned before. Next, we move on to the parallel configuration of two pumps. When there are two inlets involved, the relationship between Q total is Q1 plus Q2. So you're going to have an independent value for Q for each pump that we are using. But when it comes to H value over here, there are actually one pressure increase region, which is here and here. Even though it's at two different locations, this is the same. One increase over here, one increase over here. So the relationship between H is just H1 equals to H2. Again, we're going to plot the H and Q values on a pump performance curve. At a specific H value, which I'm going to name H0 over here, going here, you can clearly see that there is two different Q values involved over here. And this shows you that the Q values are independent.
This is the apparatus that we use in our experiment. The first component that we have in the centrifugal pump is the main isolator. This is the main isolator. And this, we have the main switch for the first stage pump for the speed control, and this is the second stage pump speed control. So to know the speed here, we will adjust it by controlling this thing. By switch. This we have two force, which is this force 1 and force 2, which we need to make sure that it becomes equilibrium to this point. Next we have pump. Two pump here. This is the first pump and this is the second pump. This is the control valve. The control valve is to control the flow rate for this pump. This is the manometer. Manometer is function to measure the mercury level for the neck head. So make sure our eyes is parallel to the meniscus of the mercury. Next we have a delivery section 1. Delivery 2 and suction 2.
Now I'm going to explain about the procedure of the single pump. As we know, the water will fall into the eye of the impeller and discharge out from the wallet. First of all, we have to make sure the check valve is closed. Then turn on the auxiliary pump and make sure the discharge valve is fully open. After that, set the pump at a speed of 2000 rpm. We have to adjust the force until it's parallel to the beat and note down the force. Meanwhile, we have to record the pump head, delivery pressure D1, section pressure S1 with the maximum flow rate. Next, adjust the control valve to change the flow rate and take 5 different readings at different flow rates. Repeat the step for the pump at a speed at 3000 rpm.
So now I would like to talk about the water flow in series pump. It is different from the single pump as it involves two single pumps operate in the same manner as a two-stage centrifugal pumps. The discharge side of the first pump is connected to the suction side of the second pump. Therefore, it consists of only one inlet and one outlet. We have to ensure that the check valve is turned in this direction so that water will flow in this direction and entering the inlet of the second pump and discharge to the outlet of the second pump. Then the procedure in single pump are repeated. Never forget to record the pump head and the discharge pressure D2 and suction pressure S1. Put down the force at pump 1 and pump 2. And then we can repeat the step for pump speed at 3000 RPM. For two identical pumps in series, each of the pumps is putting energy into the pumping fluid so that the resultant head is the sum of the individual head at the same flow rate.
Now I'll talk a bit about water flow in parallel pumps. What is a parallel pump? A parallel pump is two pumps that are connected to each other parallel. The way how we run a parallel pump experiment is similar to the series pump experiment, but the only difference is that a parallel pump has two inlet and one outlet, while a series pump has one inlet and one outlet. So before we start conducting the experiment, we have to make sure that this valve is open and the check valve is closed so that the water can flow parallelly. The procedure is exactly the same as a single pump and series pump, where we have to record the pump's head first from the manometer, and then we will record the suction and the delivery pressure of each pump, which is S1, S2, D1 and D2. And the last thing we need to record is the forces of each pump, which is F1 and F2. A pump is mainly used to overcome larger volume flows.
In conclusion, the efficiency of parallel and series pump should be higher than single pump for the both velocity of 2000 rpm and 3000 rpm. It also can be seen that the efficiency of in series is better for low flow rate and higher head interval. This is because the fluid pressure increases as the flow continues over each pump, such as how multi-stage pump works. Putting your pump in parallel can get low head interval and higher flow rate that the series pump cannot supply. For the application, the centrifugal pump will use in building to supply water as a booster. The design of centrifugal pump makes them useful for the pumping sewage. Then they are also used in fire protection and for the heating and cooling application. In addition, they are popular in beverage, dairy, food and light chemical industry.